we're in the unit of instruction where a lot of students seem to confuse the difference between variables and units of measurement. They aren't the same thing. So this lesson is about understanding the difference. An awful lot of the time, students confuse the difference between variables and units of measurement, and it really messes you up when you're doing calculations with gas laws especially. Variables are symbols we use for any kind of measurement within that dimension of measurement. So for instance, if we're measuring distance, okay, what kind of units of measurement measure distance? What kind of units of measurement measure distance? Milliliters? Huh? Yeah, let's stick with metric because we kind of stay away from the English measurements. Did you say milliliters? Did I misunderstand you? Oh, good, because it is millimeters. Okay. Centimeters. Oh, yeah, don't use yards, please. No. What did you say? Meters? Kilometers? Okay, so lots of, Yeah, we can go on. All right. Anything that's a proper prefix in front of meters, that's a unit of distance. Okay. We could also talk about things like, I don't know, a light year, for example. Okay, but we won't go there. All right. How about if we're measuring volume? What units of measurement do we use for measuring volume? Milliliters is one. Okay. Sure. Any appropriate prefix in front of liter will give you a SI unit, or not really SI unit, but a metric system unit for volume. So milliliters, centiliters, kiloliters. Okay. All right. Liters. Yeah, there you go. Lots of those. How about pressure? What units of pressure do we use? Well, we have three that we have to use in here that are on your test references. Atmospheres is one. Okay. Torr. And a lot of times we write it with a lowercase t, but really it probably ought to be written with a capital T. It's kind of a shorthand version of torricelli, so it is kind of named for somebody. And that mercury one, yeah, millimeters of mercury. Okay, millimeters of mercury. All right. One that we don't use in here, and it's kind of odd because it is the SI unit, or at least it's based on the SI unit, is either pascals or kilopascals. Okay, and you can actually convert directly between. Remember one of the things we did when we did that Boyle's Law example out in the hallway? We said that pressure is a force applied to an area. Well, all the math works out for that as long as you're using pascals. How about N? What does N stand for? Moles, and that's all it is. Okay, nothing else. Although we do shorthand it sometimes to MOL. And then T. How do we measure T? Kelvin. And when we're doing, we do use degrees Celsius, but when we're doing gas law problems, we have to convert to Kelvin first. And Kelvin is a capital K. Now, the thing that you've got to remember that's really, really important is that units of measurement can't be replaced in an equation. Okay, they are the actual units of measurement for whatever we're measuring. The variables are designed to be replaced. Okay, so you plug a number with one of these units of measurement in for one of these variables. And this is where a lot of students kind of, I don't know, they just kind of lose it on the test or something, and they'll look at the ideal gas law and look at the ideal gas constant and start plugging in temperature for the K in the ideal gas constant. You can't do that. Okay, you can't plug in a temperature for K in the ideal gas constant. Does that make sense? Yes? What's in the ideal gas constant is 4 different units of measurement, and you can't change them around. You have to keep those 4 units of measurement, all right? Because they allow you to actually cancel out units for the calculations. Any questions about that? All right, so R, there's a lot of different versions of R, we said. The one that includes atmospheres is 0.0821 liters times atmospheres over Kelvin times moles. Okay? And you can't plug in something for these. Okay, if you determine how many moles there are in something, you can't plug it in right here. It doesn't belong there. It only belongs there if there was an N, but there's not. That's a unit of measurement here in the R value we have that includes atmospheres. You can't plug in a number and a unit of measurement here.